Let's talk about Python. It's flexible, it's powerful, and pretty much everyone loves it. But it's got this reputation, right? A reputation for being kind of slow. Well, today, we're going to blow that idea right out of the water.
I mean, this is the classic trade-off we always hear about, isn't it? You get simplicity, but you sacrifice speed. Oh, Python is just slow compared to C. But what if that's not the right way to think about it at all? What if this speed isn't about the language itself, but about how you're using it?
See, here's the thing. The idea that Python is just a slow language, it's really a big misunderstanding. The truth is, all the speed you could ever want is already baked right in, just waiting for you to unlock it, with a few powerful techniques that, honestly, most people just don't know about.
And that's exactly what we're going to do in this explainer. We're going to pull back the curtain and show you the secrets that can take your Python code from sluggish to seriously, seriously fast. So let's dive in. Okay, our first stop is all about memory. Now, I know memory management doesn't sound super glamorous, but trust me, this is where you can find some of the biggest and easiest performance wins. So let's talk about the hidden cost of one of Python's best features, its flexibility. By default, every time you create an object from a class, Python uses a dictionary in the background to store all its attributes. Now, that's great for flexibility. You can add stuff on the fly, but it means every single object is carrying around this extra memory-heavy baggage.
And you can really see the impact here. A single, pretty simple class instance can eat up 520 bytes of memory. Okay, that might not sound like a lot for one object, but what happens when you create thousands of them, or millions? Suddenly, your application's memory usage just goes through the roof.
So how do we fix this? Well, the fix is surprisingly simple. It's just one line of code using a little magic word, underscore slots. When you define underscore slots, you're basically telling Python, hey, I know exactly what attributes my objects are going to have. You can ditch that big, clunky dictionary and use a much leaner, more compact data structure instead.
And just look at the results. It's the exact same class, doing the exact same thing, but now it only takes up 120 bytes. We just went from 520 down to 120 with one line of code. That's incredible. We're talking about a memory reduction of nearly 80%. And get this, it's not just about saving RAM. Accessing those attributes actually gets faster too. It's a massive win-win.
And this whole memory saving idea applies to big data sets too. Instead of loading some huge file into a list, which just eats up all your memory at once, we can use a generator. A generator is, well, it's lazy in a good way. It produces values one by one, only when you ask for them. So your memory footprint stays tiny no matter how ridiculously big the dataset is. Okay, so we've cleaned up our memory usage. Now for the really fun part, raw acceleration. A lot of people don't realize this, but a huge chunk of Python is actually written in C. And learning how to cap into that C core is the secret to unlocking some truly mind-blowing performance. Think about a simple task, like summing up a list of numbers. You could write your own for loop, right? And yeah, it would totally work. But why would you do that? Python's built-in sum function isn't just cleaner to write. It's a highly optimized piece of C code running under the hood. And the performance difference is not subtle. In pretty much any test, using the built-in sum is over twice as fast as writing your own Python loop. So the takeaway here is really simple. Always, always reach for the built-in function first. You're not just writing cleaner code. You're literally plugging into a finely tuned C-powered engine. And this same principle applies to third-party libraries, especially when you're doing heavy-duty number crunching. Python lists, they're just not built for that. This is where a library like NumPy comes in. It's also implemented in C, and it lets you perform these complex math operations on huge arrays of data at blistering speeds. How much faster, you ask? Well, we are talking over 15 times faster for something as simple as squaring every number in a big array. This is exactly why, if you're in data science or machine learning, NumPy isn't just a nice-to-have, it is absolutely essential.
But what if even that isn't enough? What if you have one critical piece of your code that needs the absolute maximum speed possible? Well, for those moments, there's Cython. Think of it as Python with superpowers. It lets you write Python-like code, but with C-style type declarations, and then it compiles that code directly into C. You wouldn't use it for your whole app, but for that one bottleneck, it's like strapping a rocket engine to your code. All right, so far we've optimized what our code is. Now let's change how our code runs. This is where we get into some really powerful concepts that can fundamentally change the entire execution model for some massive, massive speedups. Have you ever wished you could just clone yourself to get more work done faster? Well, in programming, that's pretty much what concurrency is. By using Python's multiprocessing library, you can take a big, heavy task, break it into smaller pieces, and have all the different cores on your CPU work on them at the exact same time. And the process is actually pretty straightforward. You find a task that can be broken up, like processing a whole folder of images, you split the work, you farm it out to a bunch of different processes, and then you just collect the results at the end. The time savings can be just enormous, turning a job that might have taken minutes into one that takes just a few seconds. Okay, finally, what if I told you that you could make your code faster without changing a single line? Well, meet PyPy. It's an alternative Python interpreter, and it has this incredibly clever trick up its sleeve called just-in-time compilation, or JIT. Think of it like this. Regular Python reads your code line by line, every single time. PyPy is smarter. It watches your code as it runs. It identifies the parts you use the most, the hotspots, and compiles just those pieces into super fast machine code right on the fly. And that's the magic of PyPy. For a lot of applications, you can just drop it in as a replacement for the standard Python interpreter, and boom, you get an instant, significant performance boost. It's probably one of the easiest ways to get a free speed upgrade.
So there you have it. The secret to fast Python isn't just one thing. It's a whole toolkit. It's about writing smarter, leaner code that's conscious of memory. It's about tapping into the raw power of C that's already living inside the Python ecosystem. And it's about rethinking how your code actually executes to take full advantage of the awesome hardware we have today.
So the next time you hear someone say, Python is slow, you'll know that's only half the story. The performance is there, it's real, and it's just waiting under the surface. The only question left is, how are you going to unlock it?